Greetings and salutations. In today's video we're going to be focusing on linear sequences. So this is a pattern I'm sure we've all seen before. But when it comes to linear sequences, there are certain terms we have to remember. So this pattern, 2, 4, 6, 8, 10, 12, 14, is going up in twos, isn't it? So you're increasing by 2 every time. This increasement, or sometimes can be decreasing, is called the difference. Now with the actual whole pattern, the whole thing is called a sequence. And then if you were to talk about one number or letter or specific design in a sequence, it would be called a term. So if I were to say the number 4 from this sequence, that this is a term. So this is a term, 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 and so on and so forth. With these sequences, there is a formula to keep in mind. So the formula is Tn equals A plus n take 1 d. Tn. So Tn is a term that you are going to constantly hear about when you are discovering sequences. Typically, they will ask you a question like, okay, here is a pattern. Now I want you to find the 50th term in this pattern. Now, obviously, there's two ways to do this. You can go, okay, 2, 4, 6, 8, 10, 12, 14, and keep going until you've hit the 50th term. Although that is very time consuming, but there is a trick that you can use, which is this lovely formula right here. So typically the A stands for the first term. So in this example, this would be the first term because 2, well, it's the first term in this sequence. N would stay the same. The N we do not touch for now, and I'll explain later why. The 1, we just leave it. The D stands for difference. So the difference of the pattern, okay? And let us know that this is the first difference, okay? This is the first difference within the pattern. So let's just bracket that and say this is the first difference, okay? Once we solve this formula, we get something called the nth term. Now this nth term, let's just say it's magical. You can find absolutely any term in this sequence by using that nth term. Now let me visually explain this. So let's use this formula and plot it into the sequence and find our nth term. So Tn is equal to A plus n take 1 d. We have to change the A and the d. So A is the first term in the sequence. So our first term is the number 2. So 2 plus n take 1, and our difference within this sequence is 2. And plus 2, shall we note. So now this looks quite funny, doesn't it? Because usually there is no number after a bracket, so let's change that. Let's put this number 2 right before the bracket. So 2 plus 2, n take 1. As well as, please note that I have not changed the symbol of that 2. Okay, now I can solve Tn. So I'm going to multiply this bracket out, 2 plus 2 and minus 2. So now Tn, and let's put this Tn first, okay? We're going to bring the Tn together, okay? I'll explain why. Tn, and then we're left with plus 2 minus 2, so that just gives us Tn is equal to 2n. Now, this is our nth term, okay? Once we've solved, this is our nth term. As I said, this is something magical, okay? Now, by using this, okay, and remember, this specific, let's just say, formula, shall we say? This specific formula can be only addressed to this sequence, okay? If I use this formula with another sequence, it will not work because this nth term is specifically for this sequence, if that makes sense. So, our goal here is to find T50, isn't it? So, let's find T50. Now we change the ends. So we leave the T, okay? T, and instead of the ends, we'll replace it with the term that we want to figure out. We want to find the 50th term. So we'll put 50 in replacement of the ends. 2 and 50. Now, T50, so the term 50 is equal to 2 multiplied by 50. Or in other words, the 50th term is equal to 100. And that's it. So that is the 50th term of this sequence. But you may ask, how do you know that? Well, I'm not going to sit here and physically count out the sequence all the way to 100. I'm not bothered for that. But let's just check if it is. So we said that Tn equals 2n. This is our nth term, right? This is our sequence right in front of us. Instead of finding the 100 term or the 2000 term or whatever, and those are realistic questions that they do ask you, let's find, for example, the third term, okay? There's 1, 2, 3, 4, 5, 6, 7. There's 7 terms in the sequence. Let's find the third one, okay? Now, when I solve for this, I should get 6 because, well, it's physically right in front of us. It should be 6. So Tn equals 2n. As I said, you take out the n and you replace it with the term that you want to find. So it's T, the third term, so we put T3 and then 2 and we replace the n with 3. So T3 is equal to 6. And while you look at that, the third term in the sequence is 6. So we know that we can actually trust this nth term. Now with this, you can find any term in this sequence as mentioned. You can find the 2000 term, you can find the 89,572nd term, you can find anything really. Now let's try another question. Say you are given the sequence 7, 11, 15, and 19, okay? And you are told 2 things.
Eventually.
Break this question up. We are told to do 2 things. Find the nth term, aka the magical formula, let's just say. So this is the first thing we have to do. Second thing we have to do is to find the 20th term in this sequence. Okay, so that's the second thing we need to do. First thing when it comes to sequences is you must find the difference, okay? What is the difference? Well, 11 take 7 is 4, so you're increasing by 4. 15 take 11, you're increasing by 4. 19 take 15, you're increasing by 4. As I've mentioned, this is our first difference, okay? And we've noticed that with both of these examples, right, the 2, 4, 6 going up in 2s, and the other example going up in 4s, the differences are constant. Okay, and that is a key thing to remember when identifying sequences because there are different types of sequences, but the one we're focusing now is linear sequences. So by just looking at this sequence and finding out the difference between each term, we can say that this is a linear sequence because the first difference is the same. It is a constant thing. It is not changing. It is the same. So that is one important thing to note. Okay, now let us use the formula. So the formula is Tn equals A plus n take 1 d. Tn is equal to A. Our first term is 7 plus n take 1. And our difference is 4. So now we bring the 4 to the other side just to multiply out this bracket. So 7 plus 4 and take 1. Then Tn is equal to 7. We're going to multiply out the bracket plus 4n minus 4. And then we're going to bring this plus 4 right to the start. 4n plus 7 minus 4. Tn is equal to 4n plus 7 minus 4 is plus 3. And then this is our nth term. So please note that this is our nth term. As I've mentioned, with this magical formula, you can find any term within this sequence. So we've done the first part of the question. So find the nth term, we have done so. Now it's asking us to find T20. So to find T20, we're going to use our nth term. So Tn is equal to 4n plus 3. So we're going to replace the n with the term that we desire to find. So T20 is equal to 420 plus 3. Then T20, 4 multiplied by 20 is 80 plus 3. So then T20 is equal to 83. Now once again, we can check if this nth term is, valid to use. So Tn is equal to 4n plus 3. Okay, let's do the same thing that we did last time. So there are 4 terms within this sequence. Let's find the second term of this sequence. So we want to find the second term. So T2 is equal to 4, replace that with a 2, plus 3. So T2 is equal to 8 plus 3, and then 8 plus 3 gives us 11, and we know that it is right. Let's say you're given this question. You're given the nth term, but you are told to find the first, second, third, fourth, and fifth term within this sequence, but we don't even know the sequence. So this is our nth term, right? As mentioned, Tn is equal to 2n plus 3. We have to find all of these terms, but how? Well, we're going to do the same what we've been doing. T1 is equal to 2 bracket 1 plus 3 because we are taking out the n and we are placing it with the term that we desire to find. So 2 multiplied by 1 is 2, and 2 plus 3 is 5. So then to find T2, we'll do the same. 2 bracket 2 plus 3. So 2 multiplied by 2 is 4, and 4 plus 3 is 7. And that is our second term. Our first and second term, now we find our third term. So T3 is equal to 2 bracket 3 plus 3. Now 2 multiplied by 3 is 6, 6 plus 3 is 9. So this is our third term. T4, 2 multiplied by 4 plus 3. So 2 multiplied by 4 is 8, and 8 plus 3 is 11. This is our fourth term. T5, to find T5, we'll replace the n with 5. So 2 bracket 5 plus 3. So 2 multiplied by 5 is 10, and 10 plus 3 is 13, and this is our fifth term. So then our sequence should be 5, 7, 9, 11, and 13. And this is our sequence. Well, it's pretty much straightforward. Let's just explore a little more and let's just use this sequence, find the nth term to see if it matches. So, what is the difference? Well, the difference, 5 to 7 is plus 2, 7 to 9 is plus 2, 9 to 11 is plus 2, and 11 to 13 is plus 2. And our first difference is constant. We know that this is a linear sequence. So, we'll use our formula. Tn is equal to A plus n take 1 d. Okay, so Tn is equal to A. A is our first term, so that is 5 plus n take 1. Our difference is 2. So then Tn is equal to 5, and I'll bring the 2 over the other side, plus 2, n take 1. And then Tn is equal to 5. We're going to multiply out the brackets, plus 2n minus 2. And then Tn is equal to, we'll put 2n at the start, 2n plus 5 minus 2 is equal to Tn is equal to 2n plus 3. And this is our nth term. And would you look at that? Whoa. This and this is the exact same. So as you can see, the nth term plays a crucial part in linear sequences. But if you don't know, how to use it, then its value is suddenly worthless. So that is that. Thank you for watching.